All right, in this video, we're going to talk about the elimination method. So to solve a system of equations by elimination, the first thing we want to do is we want to align the equations. And we're going to align them based off the variables. We'll see that in an example. Multiple one or both equations, multiply one or both equations by a number to result in a variable with the same coefficients. So again, this is just making sure our coefficients are the same so that we can eliminate. Subtract the equation to eliminate a variable, and then we're going to solve. And then we're going to use substitution to solve back to get the other variable. So when we are dealing with systems of equations, we want to make sure we get both our x and our y values. When we get to 3 by 3 systems, we're going to get our x, our y, and our z value. So let's look at this first example. So in this first problem, we have these two equations, and notice that none of these can potentially cancel out. So I want us to think about what, first we identify a variable that we want to cancel out. So I'm going to go ahead and use y. So in order to cancel this out, like if I was going to add these two together, positive y minus 6y doesn't go away. However, if I take this entire first equation and multiply it by 6, I am now, as long as I multiply every single element by 6, I am now changing, I'm not changing the equation, I'm just multiplying it by 6. So this becomes 18x plus 6y equals negative 150. So again, because I multiplied both sides, I have not changed the equation, so that's okay. So I'm just going to write this other equation back. So now notice that when I add these two equations, just like I would add numbers, so think of back to elementary school if you had 123, and you wanted to add, 104, we would add these two together, our ones place, add the tens place, and then we'd add the hundreds place. So that's kind of what we're going to do here. We're going to add our constants here, so negative 50 plus, so we're adding this equation, plus 62. Negative 50 plus 62 gives us negative 88. And then notice positive 6y minus 6y. These are now gone. They cancel out. So now I'm left with 18x minus 7y. So that gives us a positive 11x. We're going to go ahead and divide both sides by 11. And we'd end up with x is equal to negative 8. Are we done? No, because we still don't know what the y value is. So now I pick one of the equations that I want to use, right? And so I'm going to go ahead and use the first one. So I'm going to say 3 times negative 8 plus y equals negative 25. 3 times negative 8, that gives me a negative 24, plus y equals negative 25. I'm just going to add 24 to both sides. So I'd end up with y equals negative 1. So this ends up being negative 8, comma, negative 1 is our solution. So this is our unique solution here. All right, let's look at the next one, number 10. So in number 10, I'm going to go ahead and decide which one of these variables I want to go ahead and eliminate. And notice how this is an 8, and notice how this is a 4. So if I take 4 and I multiply it by 2, I'll get 8. So I'm going to go ahead and take this first one, and I'm going to go ahead and multiply it by negative 2. So in multiplying it by negative 2, I get 4 times negative 2. That gives me a negative 8x equals negative 10y. Negative 2 times 10 gives me minus 20. And then I have 8x plus 9y equals 58. All right, so before we continue here, notice how I have a plus 9y on this side and I have a negative 10y on this side. So my equal signs are definitely not lined up. So I need to make sure that I move that 10y over So I'm going to move this 10y over to the side. So when I do that, I end up with negative 8x plus 10y equals negative 20. I'm just going to recopy that equation below, plus 9y equals 58. So now let's combine these two items. So negative 8x plus 8x, that goes away. But now I have 10y plus 9y. This gives me 19y. And that's going to equal 58, well, negative 20 plus 58, which gives me 38. I'm going to go ahead and divide both sides by 19. And I get y is equal to 2. Okay. All right, again, remember, I'm not done, so I need to pick one of the equations, and I can pick whichever equation I want. So let's go ahead and pick the first one. So 4 times x, I don't know what x is, equals 5 times 2 plus 10. Well, 4x equals 10 plus 10. So 4x equals 20. Therefore, if I divide both sides by 4, I end up with x equals 5. So we see then that the solution is 5, 2. So all of these are, so far, are unique solutions. All right, let's take a look at number 11 here. So again, I'm going to find one that I can easily cancel out. But notice that 8 times 3 and 2 times 11 are not multiples of each other. So I'm just going to have to pick one and multiply both the equations by something. So I'm going to take the top and I'm going to multiply it by 3. I'm going to go ahead and get rid of that x. I'm going to take the bottom and I'm going to go ahead and multiply it by 8. But because I want one of them to cancel out, I'm going to multiply by negative 8. So this equation will then turn into 24x minus 6y equals negative 96. The next one, I'm going to multiply this all out. Again, negative 24x. So remember that negative times a negative, that's going to give me a positive 88y equals a negative times a negative. Again, I'm going to get a positive there. So it's going to be 424 positive. Make sure our equal signs line up, our y's are lining up, our x's are lining up, and our constants are lining up. So now when I go ahead and do this addition, notice how my 24's cancel out, they go away. Positive 88 minus 6y, that's going to give me an 82y. And then 424 minus 96 is going to give me 328. So let's go ahead and divide both of these by 82. So I end up with y equals 4. So let's come over here. I'm going to pick one of these equations. I'm going to go ahead and pick the first one. So 8 times 4 minus 2y equals negative 32. 8 times 4 gives me 32. Oh, I plugged in x for 4. Sorry, I plugged in, yeah. Instead of plugging it in for y, I plugged it in for x. So I'm going to be 8x minus 2 times 4 equals negative 32. 8x, 2 times 4 is 8. Minus 8 equals negative 32. So 8x equals, I'm going to add 8 to both sides. I get negative 24. So I'm going to divide both sides by 8 now. And I end up with x equaling negative 3. So then my solution here is negative 3, 4. Okay. All right, let's take a look at this next one. So I'm going to pick a variable. Notice that these equations are not lined up. So I'm going to go ahead and put all the variables on one side and leave the constant on the other side. So I'm going to change this equation to be 6y minus 9x equals 39. And so then this would be 2y minus 3x equals 13. So I'm going to pick a variable to get rid of. So let's go ahead and pick the x value. So if I look at the x value to get rid of, notice that if I take 3 and I multiply it by 3 times 3, that will give me 9, and it would end up canceling out. But more importantly, I need to make sure that the signs also cancel out. So I'm going to take this bottom equation, I'm going to multiply it by -3. Oops. By -3. So then that top equation still is 6y minus 9x equals 39. And then that bottom equation, it's going to be 3 times that 2y, so it's going to be -6y plus 9x equals -3 times 13 gives me a -39. All right, so what happens here? Notice 6y minus 6y. Okay, well that cancels out. So maybe I meant to get rid of the y's, but then I get so negative 9x plus 9x. That also cancels out. And then 39 minus 39, that also cancels out. So this is another way of saying 0 equals 0. Now this is a true statement. Also notice how these two are the same exact equation. So that meant that these two were the same exact equation, except it was just hidden because one was a multiple of the other. So because 0 does equal 0 and it's a true statement, this is an indication where we have infinite solutions. Or remember, we can say consistent, and it's going to be consistent and dependent. Let me change colors here. This is going to be a consistent dependent solution. Okay. Alrighty. So that's how we solve it by elimination. So come back to review real quick. We're going to align the equations. We want our x's with our x's, our y's with our y's, and our equals with our equal. We're going to multiply one or both equations by a number to result in a variable with the same coefficient so that we can cancel that out. We're going to subtract the equations to eliminate the variable, and then we're going to solve. So that's essentially what we are doing here to go ahead and eliminate one of those variables to be able to solve. Let's take a look at applications. Let's see, there's a couple questions here. Why don't we go ahead and do this in the next video?